In this video, I'll show you how to solve the ALEKS problem called finding isoelectronic atoms. This ALEKS problem is going to ask us to write the symbol for 3 different atoms or ions that have a specific number of electrons. My problem is asking me to write the symbol for atoms or ions that have 11 electrons. The problem is going to specify whether it wants you to write either a cation or an anion. This particular problem is asking me to write the symbols for cations only, but it could also be asking you to write symbols for anions instead of cations. I am going to show you how to do both. So I'm going to show you how to do the cations first, and then we'll talk about the anions. You are able to write the symbol for an atom, and so you should definitely do at least one, well, you should definitely do one atom, and then the other 2 should be ions. The number of electrons, so one thing that we want to kind of make a note of for an atom, the number of protons, I'm just going to write that as the number of protons. That's my little notation for that. The number of protons are always equal to the number of electrons for an atom. So if we know that a substance has 11 electrons in it, its atom will also have 11 protons in it. I'm going to go to a periodic table. I'm going to find atomic number 11. That is sodium. That number 11 right there means that sodium has 11 protons, and it also, as an atom, has 11 electrons. So that's one of the answers, one of our possible answers to this problem. This particular problem where we're talking about 11 electrons. Now, since I'm being asked to write specifically about cations, cations are ions that have more protons than electrons. So the number of protons is greater than the number of electrons. So for my cations in this particular problem, they all need to be things that have more protons than 11 in this case, because my number of electrons is stuck at 11 based off of the conditions of this problem. So I need to find atoms or ions that have more protons than 11. And the easiest way for me to do that, let me just get this out of the way, is to just go over to the next spot on the periodic table. Magnesium has 12 protons. And as a cation, magnesium could absolutely have 11 electrons. There'd be no issues with that at all. If magnesium had only 11 electrons, it would have a charge of +1, which I would write with just a plus symbol. How do I know the charge is +1? Because I have 12 protons and 11 electrons. I have 12 positively charged particles, 11 negatively charged particles. All together, that's, works itself out to be a total of plus 1 charge. And in general, if you just move over one spot on the periodic table, the charge on that ion is going to be a +1. Okay, so I'm just going to kind of follow this same pattern. I'm just going to go to the next element on the periodic table, the next one over, which is element number 13. That is aluminum. And aluminum has 13 protons. It could absolutely have 11 electrons. That would be fine. And the formula for that would be Al2+. How do I know, again, how do I know it's 2+? Because it has 13 positively charged particles, 11 negatively charged particles. When I combine those particles together, I'm going to end with a total of a +2 charge. So this is how you would do the problem if you were being asked specifically about cations. Let's pretend like we were being asked about an anion, because ALEKS right here could just say anion and not make any other change, and that would be perfectly fine. So if you were looking at the anion version of the problem, your first answer should definitely be the atom itself with 11 electrons and 11 protons, the atom with the same number of protons as electrons. Anions are substances, particles, that have fewer protons than electrons. So the number of protons is less than the number of electrons. And again, in this problem, we have been restricted to 11 electrons specifically. So if I'm writing the formula for anions, I need to find things that have a number of protons less than 11. So in this time, I'm moving in the other direction on the periodic table. I'm going backwards. From 11, I'm going to go backwards to element number 10. That's neon. That is neon. And if neon normally has 10 protons and 10 electrons, but in this problem it's telling us we're going to pretend like it has 11 electrons. If neon had 11 electrons, if it had 11 negatively charged particles compared to 10 positively charged particles, the charge on that ion would be a -1. And hopefully you're starting to see the pattern. We're going to move backwards from element number 11. We're going to go back to element number 9. We're going to move back one more spot. That's fluorine. Fluorine has 9 protons, and if fluorine had 11 electrons, then it would have a -2 charge.